Hey there, welcome back to another episode of Hipster Codes. This is Hipster GW. Today we're going to be talking about Python classes. So, Python classes, what are they? Why would you use them? Well, they're one of the most used concepts in all of object-oriented programming. And the reason that you would use a class is so that you can model the way that data will be contained. And then whenever you create an object out of that class, you can include specific values for that specific class, the way that it's modeled. So, for an example, if you have a movie theater and you want to keep track of all the movies that are in it, you might have some information in the movie theater on, what movies are being shown, what the prices are of everything. You can contain that all inside a class or a bunch of classes if you wanted to. And not only do they have their own attributes, which are pieces of data that pertain to that specific class instance, but they also have methods, which are like functions. They basically are functions that operate on that specific instance of the class to manipulate the data inside, so you have full control over what's happening with the class. Might make a little bit more sense if we do a more practical example, but this sort of goes into the broader topic of Python data structures that we've been going over the last couple of weeks. So let's just do an example. So let's say that we have, let me go here, and we're going to talk about instance attributes, which are values, sort of like variables, right? And then we will also go over instance methods, which are sort of like functions. So let's say that we wanted to model data about specific superheroes. So there are certain things that all superheroes have in common. Let's say every superhero has a name. Every superhero might have an alias. They might have a special power. They might have a weakness. So because they all have that, but each superhero has a different weakness and a different name and a different alias, we could use a class to model the data. Then whenever we create objects out of that data, we can give them all specific details to match a specific superhero. So the way that you create a class in Python, you're going to type the keyword class, and then this is where we break from the snake case convention. Usually you'll see Pascal case, but for sure the first letter of a class is almost always going to be capitalized in Python. This is a very commonly used convention, and it's usually a way to know that you're dealing with a class whenever you see this capital letter. So I'm going to do capital superhero. We don't have to invoke it. Actually, whenever you do parentheses right here, like you would with a function, this isn't passing in parameters or anything like that, or arguments for a function. This actually allows you to inherit from parent classes. I'm not going to go over inheritance in this video, but you might see it in the future. But we just need to do a hard colon and then go down to the next line, and we're going to tab in. So you have to have something. I'm going to do just pass for now. So we have this superhero class. It's really useless, but we could still utilize it if we wanted to. So if we wanted to create two superheroes, let's say we wanted to create Iron Man and we wanted to create Batman. So I have two variables here for two superheroes, and they're going to be equal to an object, an instantiation of this class. So think about the class like a blueprint, and the blueprint models what that specific superhero should look like, but the specific details are within the object or the instance. Objects have a location on RAM, they are in memory, right? So they're temporary there whenever you run the actual program. But the class itself isn't an actual superhero, it's the blueprint for a superhero. Just like a blueprint for a house isn't a house, but it's used to help construct a house. The blueprint for this superhero class isn't a superhero, but it's used to help construct a superhero. So in order to actually construct or instantiate or create an object out of the superhero class, here we will call it like a function. Right now we don't have anything to pass in, so we can't actually pass any arguments in. So we're just going to instantiate it like this and assign it to the variable Iron Man. Here, we'll worry about Batman in a minute. We'll just do Iron Man. Right now we have an empty class with no attributes or methods to it. So we can actually add attributes, instance attributes, which is all we're going to worry about in this video, specific pieces of data on this specific object that will remain while we're running the program. And so the way that we would do that is, let's say that we wanted to give a name attribute for Iron Man. Remember, this is the name of the variable. This is how we access the piece of data being our instantiated class. So if we wanted to update the actual name, we could do ironman.name equals, and then we can actually do a capital I Iron Man because, this is snake case, so we're going to leave this lowercase. But this will be the actual string for the name. Then we say that we want to have a alias, and this could be Tony Stark. And let's give Iron Man a power level, and this can be an integer. I don't know, we can give him 15, 20, 50. There we go, 50, sounds good. And so now you can see if we add these attributes, we are essentially creating attributes and assigning them variables after we have instantiated Iron Man down here. So if we want to actually access this information, we could print it, and we could see that we can actually get our Iron Man name, and we can get our Iron Man alias, and we can get our Iron Man power level. So now if we run our program, assuming I didn't make any mistakes, yep, you can see we actually printed to the console this information. It's not immediately apparent why you would want to do this because this is a lot of code. And we're doing it all in a script. The truth is you're going to actually build out logic in your programs to instantiate these classes with other variables and things like that. We're not going to worry about, more complicated examples of this in this video, but we can actually make this code a lot cleaner by including these pieces of information inside our instantiation. How do we do that? Well, other languages might have a constructor in their class. In Python, we're going to call it the initialization method or the init method. And actually, all methods start with DEF. So we're defining a method. This one's going to be $init for initializing method. This is because it's a double underscore method. You will hear the term magic method. I use the term dunder method all the time because $dunder has nothing to do with Dunder Mifflin, but has to do with the double underscores on each side. But we're actually overriding the Python behind the scenes initialization method that does nothing except all of the bare bones stuff to create a superhero class in RAM, right? So we're actually going to override this and allow for self. Every instance method, you always want self. What self represents is the actual object in memory. So this example of Iron Man, it represents this Iron Man variable in memory. So it's always going to be explicit whenever you define it, but implicit when you call it. I will repeat that in a minute. So we want to bring in self, then we want a name because every superhero has a name. Every superhero has an alias. Every superhero has a power level. And so now what we want to do is we actually want to assign new attributes based off of these arguments we're bringing in. Notice we're bringing in arguments like we would with any other function, and they're positional arguments. So we know that we could assign on self, which is the object in memory, a new name attribute, and it's going to be equal to the name parameter or the name argument that's being passed in. The same with alias. So we'll do self.alias equals alias and self.power level equals power level. So I've had people ask me before, this looks like we're just typing the same thing over and over again. Why do you even have to bother doing this? And it looks like you're typing the same thing because we're typing the same letters, right? Power level, name. Looks like we're doing the same thing, but what we're doing is we're going to be passing in the name argument to our initialization method in a few minutes, the alias argument, and the power level argument. And the way that you do that is you actually pass them in when you instantiate your object. And so now instead of saying ironman.name equals ironman, we're going to pass in the string ironman as the first argument that will be equal to this name parameter, and then we will assign on self a name attribute equal to this name parameter. So let's just complete this pattern real quick, and then I'll show how it actually operates. So the alias, again, is Tony Stark. In the power level, we will pass in 50. And now I can get rid of these lines of code. Actually, I'll mute them out. I'm going to mute them out so they're not actually running. But you will notice, even though I muted these lines of code out, I basically replicated the exact same thing in the initialization method so that we could just pass in these arguments once. They get instantiated, or they get set, or the attributes get set whenever we actually initialize or instantiate the object. And so you'll see it's going to look exactly the same. We get the exact same output whenever we print, but we're not printing from here. But notice we're doing the same thing because ironman is the specific variable name. So we were just adding the name attribute to that specific variable name, which here is represented by self. So you notice we didn't pass in self whenever we instantiated it. Like I said, all instance methods need self explicitly declared whenever you declare the method or define the method, but it's implicit whatever you call it, because it knows that it's actually going to say, okay, whenever we're calling this method, it's going to be on this variable name or this object that we're actually representing. So it passes itself in, it's implied. So you don't have to do it whatever you call it, but this lets it know that you're actually doing an instance method as opposed to a class method, which we'll go over in another video. So now we actually have all this information still set up. We're passing in the name, assigning it to the name attribute, alias, power level. Just to finish that last point is these are not the same thing, because what we could do is we could change this parameter name and we could make this banana. And then notice we get a nasty underline because we didn't have anything called name. So we can assign that banana, and notice it's going to work exactly the same, but anybody looking at our code is going to be like, why the heck did you call this banana? That doesn't make sense. So this is sort of helps drive home the point that these are separate things. These are the parameters or the arguments that are being passed in, and we are assigning an instance attribute that just happens to be the same word. So notice we have Ironman. Now that we have this set up, we can now do Superman. So let's do Superman. It's going to be equal to our superhero instantiated. And now notice we are calling the initialization method, whatever we instantiate our object. And now notice it wants a name, so we could do Superman. It wants an alias, so we could do Clark Kent. And it wants a power level, and we'll give him 5,000 because Superman is a big, fat cheater, and he's really good at everything just naturally, and that's why he's the worst superhero. But notice here we can print Superman.name. We can print Superman.alias. We can print Superman.power level. And so now if we call this, it's not only we have Iron Man, but we also have Superman. So we created two entirely separate and distinct objects in memory, both based on the superhero class. So again, the superhero class is the blueprint that we use to say all superheroes have these things in common. They have these attributes, but the specifics about those attributes are different. And then whenever we instantiated them, Python behind the scenes saved them into RAM, gave them specific identifier codes, and all we had to do was keep track of the variable name. And then the variable name, we could access that object in memory, down later on in our script, which is what we're doing here. And that's why we have distinctly Iron Man and Superman, two separate objects that are both from the same class, but with different specific attributes inside. One more thing is we went over a magic method here. I'll create another video specifically on other magic methods another day, but you can create your own methods as well. Let's create a method that you call on one superhero, and then you pass in another superhero, and then it's going to say which superhero is stronger. So we can call this, who is stronger? I'm never very good with names, so I always apologize. But it is an instance method. So we're going to allow it to be called on one of the two superheroes. So we're going to pass in self. But now it's like we can put in any arguments we want. So we could like pass in some sort of math if we wanted to, some sort of integer or string or whatever, but we can actually pass in another superhero. So we could do other superhero, and we know it's going to be of the superhero class. And then what we could do is we could say if self.power level is greater than other superhero dot power level. Notice they're both superhero objects, so we know that they both have a power level. We can return, let's just print for now, we won't return. We can print an F string that says self.name is stronger. Good job. We could do another elif check where we're going to check if the power level is less than the other superhero dot power level. And then we will print, sorry, bro, other superhero. And you know what? I messed that up here. So let me fix that right now. Superhero.power level. So other superhero.name is stronger. And then we could do an else statement, which means, okay, if it's not greater than or less than, that means it is equal to. And so we could just say both self.name and other superhero.name are the same strength. And I messed this up even when I tried to fix it. Okay, there we go. So now we have this new method that will just print out which superhero is stronger. We have to call it on one of our two superheroes, so let's call it on Iron Man. And so we will say Iron Man dot who is stronger. And again, we're not passing in self, but we have to pass in the other superhero. So we can pass in Superman. And now you will see it says, sorry, bro, Superman is stronger. Let's cheat. Let's give Iron Man a bunch of zeros there and run it again. Right? Iron Man is stronger. Good job. Let's make them both 5,000. And there we go. So we're actually able to call it on one of these. You can use these to actually manipulate the same, or you can actually use these methods to manipulate your attributes as well. I'll definitely go over that whenever we do a larger video on methods, but I just wanted to cover the basics of classes today. So hopefully this is starting to make sense to just bring everything home. Classes are the blueprint for how you model data. They give you the ability to create attributes and methods. Attributes keep track of specific pieces of data for that specific instantiated object. These are instance attributes, and instance methods can manipulate those pieces of data of that specific class object. And so it becomes more obvious when you work with this in more projects, but this is sort of like the baseline fundamentals of what a class is. Now, superhero, example isn't always the best example, but I think it gets the job done to lay the base framework for building out more complicated classes. If you have any questions, please leave a comment down below. Hopefully you did find this a little bit helpful to clear up some of the specifics about classes and how to think about them. Also give this video a like and also subscribe. That definitely helps. So thanks again, and we'll see you in the next video. Later.